the recording here.
All right, thank you, Tom. Good afternoon, good morning, and good evening, everyone, from wherever you're dialing in. My name is Deji Akamalafe. I'm a staff solutions architect at VMware. I'm the practice lead for Microsoft Application Virtualization on vSphere. What that means is I know most of the answers to most of the questions that are frequently asked on how to best virtualize Microsoft applications on vSphere. Today we are going to be talking about virtualizing SQL Server on the vSphere platform. Okay, and this is my first time doing this. Tom, I thank you very much for inviting me. My mission in life as the lead for Microsoft application on at VMware is to make sure that when you do virtualize your Microsoft application, especially SQL Server, your SQL Server doesn't do this. Okay, I will be going through a number of things. Most of the time I will focus on best practices and things to avoid. I've seen a lot of implementations, a lot of efforts to virtualize Microsoft SQL Server on vSphere, and I've seen a lot of them that end up bad, not performant and not reliable, and I've seen customers who get frustrated and roll back to physical. There's always this question of can we really virtualize this large, this very busy, this OLTP intensive, transaction intensive SQL workload in a virtual environment? And the answer simply is yes, you can. We've been doing it for many years, and Microsoft SQL Server happens to be one of the most virtualization friendly applications from Microsoft. And the vSphere platform, as it is today at 6.0 being the latest, 6.01 being the latest, we have increased capacity to be able to accommodate most of the production SQL Server infrastructure in the enterprise today. Unless you have SQL servers that are ordinarily larger than 128 CPUs or 4 terabytes of memory, your SQL Server is good and ready for virtualization. All right, I'd like to begin this presentation by just focusing on the common criteria for ensuring success in your virtualization effort, and I would like you to pay attention to these 4 things I'm going to show. The journey begins with the physical hardware itself. When you're trying to figure out where you should pay attention to when you want to ensure success in your virtualization effort, please do not overlook the physical hardware. The mere fact that you're virtualizing doesn't discount the importance of the physical hardware. And then also, next in line is the ESX host. Once you install the ESX hypervisor on top of the hardware, there are also places that you have to pay particular attention to ensure success. The virtual machine itself also needs your attention. And lastly, the guest operating system. I will not mention the application itself because the fact that you are virtualizing that application does not really change anything. You should not have to know that your SQL Server instance or your databases or the SQL Server itself is running in the virtual environment. If you've done your homework, if you've done if you follow the guidance as I'm going to try and articulate in this presentation, your SQL Server should not know that it is running in the virtual environment. Okay, let's get started. This is the basic. Today, if you're going to virtualize any application, we are going to expect that you're going to be running on modern hardware. These are the basic requirements for the type of hardware that you will purchase for any of your virtualization effort. It has to support the minimum. Most servers, I can't really think of any server that you will buy today that do not have these capabilities. CPU virtualization is very basic. Any server, any enterprise level server hardware will have this, memory management and IO, MMU virtualization. These are staple features of enterprise level server hardware today. All right, now that you've procured the hardware, I want to have you pay close attention to the fact that the hardware itself has to be on the VMware hardware compatibility list. We do a lot of testing, and we do engage third-party vendors, hardware vendors, and help them ensure that whatever they're putting out, including drivers, firmware, and the BIOS revs, are all certified, and they can support the features that we expect to be able to leverage through the hypervisor. On that note, please note that just merely buying a hardware that's on a hardware compatibility list doesn't really guarantee that you're going to be successful. The drivers, the firmware, the BIOS revs, and all other things on the hardware have to be always up to date. I cannot tell you how many times we've had situations where everything seems to be fine, and then there is performance problem issues, and it's all traced back to outdated drivers or firmware or BIOS revs. Always disable unused physical hardware. Any physical hardware that you're not using on that hardware, on that server, uses resources, and we want to have as much of the resources available to your virtualization effort as possible. Memory scrubbing and the scrubbing rate in BIOS, please just leave it at default. You do not need to enhance anything for the hypervisor. The default power scheme for virtualization is not optimal, and I will have a lot to say about this as I go through this. Hardware power scheme, OS power scheme, and even power schemes inside the ESX hosts at the hypervisor level are very important. And as a basic, on the hardware level, we want you to set your power scheme to OS controlled. If that's not an option, then please take the most performant option, usually high performance, is what the option will be. Take whatever is the most optimal for that hardware. If it's available, please use OS control. Turbo Boost is very good for increased performance. It's just like you overclocking your CPUs, and we like to get the maximum output out of the CPUs that we see in the host. Some hardware lets you buy more than you need as far as a CPU is concerned, and for licensing reasons you may choose to disable some of those CPUs. We encourage you to please not do that. When you size your hardware procurement, please buy as much as you need and not have to disable any of the cores in your physical hardware. Hyper-threading is highly encouraged, especially for SQL servers. There is no known technology or technical rationale for disabling hyper-threading, especially for ESX hosts that will be hosting SQL workload. NUMA is always preferred, and we ask that you ask your hardware vendor for the specifics on how to enable NUMA. We encourage you at all times to please enable NUMA. And on some hardware, the configurations are different, so please be sure to contact your hardware vendor for the information on how to enable NUMA, hyper-threading, and all the rest. So let's do a quick rundown. I will speak more specifically about each of these as we go along. Storage is number one in the list of things that make virtualization efforts go wrong. There's always a queue when you virtualize, even when you don't, but the virtualization layer also introduces additional queues that do not exist in the physical world, so please pay attention to that. It is more important that you ensure that you have increased throughput and increased bandwidth for your I/O. Virtual SCSI controller, vSCSI, we call it a VMware Virtualize, is always recommended for your SQL server. Multi-party policies in the vSphere environment affects the performance of your storage output. So please consult your storage vendor about the appropriate multi-pathing policies. It differs among storage vendors. There's this idea that the bigger your SQL Server is, the more performant it is. That may be true on a physical server, which is not the case anyway, but that may be an acceptable notion in a physical world. In the virtual infrastructure, we try to discourage that idea, and the reason is that we pool resources in a virtual environment. We pool them and we share them among multiple workloads. In that configuration, we want to be judicious in the allocation of resources, so we do not want you to give a VM more resources than it can use. That can lead to reduced performance for that hardware, for that VM. You may see a lot of several blog posts or things on the internet that tell you that if you're having network issues, look at using a different network card instead of the VMX-NEC3 network adapter inside vSphere. I'm going to tell you right now, please discount those reports. If you're using VMX-NEC3, which is what we highly recommend for your SQL Server workload, and you encounter any issues, packet drops, or anything like that, please let us know. VMX-NEC3 is the most optimal network card drivers that we have on the vSphere platform. Do not use anything else other than VMX-NEC3. The fact that you're virtualizing your SQL Server shouldn't change your administrative practice. And we encourage you to stick to what you do, what works well for you today. If you need to change other practices, it shouldn't be just because you're virtualizing. Again, the SQL Server should not know that it is being virtualized. All right. Because storage is usually the most problematic, and because we know that SQL doesn't like to wait on I/O at all, I will start the deep discussion by focusing on the storage performance layer. What I'm depicting here is a logical representation of what the storage stack looks like in a virtual environment. At the base down here, we see the physical hardware with your storage, your memory, your CPU, and everything. And up here, we see your fiber channel, and then up here we see how we abstract the storage and present it to the application inside the VM. And if you're looking, let me build this up really quick. If you're looking at my representation here, each of these components at each of these layers has its own different queue length. The array, the storage processor, your HBA, your LON, all of them have their queue depth. I will explain what that does shortly. And then when we abstract everything, we also introduce additional queue depth and throttling point. For example, the SCSI controller adapter type that you use will determine the queue depth of that controller. The number of disks will impact the performance of the adapter and the storage, the data store. And then there's something we call DNSRO, which is schedule non-request outstanding. That's the number of outstanding IOs that we can support inside vSphere. By default, that's 32. That also controls, that also has impact on your storage performance. Now, talking about queues exist everywhere. And just for as you will see in your, if you go to a store and you have a single checkout counter, as customers begin to arrive, that single cashier or checkout attendant may not be able to quickly attend to each of the customers as they are arriving. Imagine this to be your I/O and the checkout counter to be a point in the virtualization layer at the storage stack where IOs have to go through. So consider the customers you're looking at here as your IOs, and as they are arriving at a point in the stack, if the stack is busy, all the IOs in flight will have to queue up. And the objective when you send IOs from your application down to the storage stack, the objective is for you to reduce the response time as much as possible. We want to have as minimal a queue time as possible, and we also want to reduce the service time, which give us the aggregate response time. Our objective is to ensure that nothing lingers in this space. The IO gets quickly from the application down to the storage device and back to the application with minimal impact. If you were to do this in a typical SQL Server configuration, you just built your VM, you added disks, and you added a storage controller, a SCSI controller. That SCSI controller, you get one for a VM. That SCSI controller has a queue depth. Now that queue depth depends on the type of SCSI controller you use. By default, you get the LSI Logic SAS SCSI controller, which has a queue depth of 32. If you were to just simply change that to the VMware/Virtual SCSI controller, the previous SCSI, you just double the queue capacity of that storage controller, that storage stack. So, for example, if we had 4 hard drives, 4 volumes attached to a VM, and say you have your 10 DB separated, you have your transaction log separated, and you have your data all separated out onto multiple VMDKs, but they are all attached to the same SCSI controller. The IOs that are coming from all those 4 drives will be funneled through that single SCSI controller. If it were LSI Logic SAS, after the 32nd IO, we are going to queue up the rest of the IOs as they're coming through, as that controller is busy. If you just change that to previous SCSI, then we can get 64 out of that same controller at once. That just doubles your throughput just by doing that. In addition to doing that, we recommend a different scheme. We ask that you also add more than one SCSI controller. In a vSphere environment, you can have up to 4 SCSI controllers. We ask that if you are going to create a VM that is going to have a lot of volumes, disk, VMDKs, or even RDMs, it would be to your advantage to add more SCSI controllers and distribute those disks over those controllers. What happens then is we will be able to parallelize the IOs over multiple channels, and as we know, a 4-lane highway will always be faster than a single-lane highway. So what we're trying to describe here is, please don't just stick with one single SCSI controller. If the aggregate IO coming from your SQL Server and your VMs are going to be substantial, it is to your advantage to please add as many SCSI controllers as needed, up to 4 in the current versions of vSphere. Okay. There is also the question of, should we create larger data stores or smaller data stores? When we introduce larger data store capacity in vSphere 5.5, we let you create up to 62 terabytes of disk and VMDKs, and people were very happy about that because now they saw the potential to be able to create multiple VMDKs and put them in one data store and reduce the number of data stores they have to manage in the environment. While this is a good idea, please do not forget, again, the queue depth. A data store inherits the queue depth of the LUN on which it's created. By default, they are usually 32 as well. The LUN can go up to 254, just like the previous SCSI controller can go up to 254. Now, in the default configuration of 32 IOs, if you create multiple VMs and you create multiple data VMDKs for them, and you put all of them in one data store, what do you suppose will happen? the aggregate I/O coming from all those VMDKs and those VMs will most likely saturate that data store because it is limited by the queue depth of the LUN. So while keeping your data stores minimal can be administratively good for you, for your workload, they may not be the best option. It is impossible for me, even though I've been doing this for a long time, it's impossible for me to tell you that this is a certain number, a gigabyte or terabyte is the recommended size of data stores. It is workload dependent. You will have to test it with any of your benchmarking tools like disk SPD, IO-meter, and any other SQL benchmarking tool that you have at your disposal. You will have to benchmark that and see what size of data store will be acceptable from IO perspective in your environment. If you're using IP storage, we encourage you to use jumbo frames if you have it. If you don't have jumbo frames, we encourage you to try and shoot for 10 gig in network because you want to ensure increase or high bandwidth for your storage related IOs. I mentioned the DSNRO disk schedule outstanding request outstanding. There's also another thing about admittance policies, and I've just included a KB here for more learning if you're interested in getting all the details about that. The admittance policy that we have in the VM kernel differs depending on whether you use a storage IO control or not. It's we recommend that just to keep things simple, use dedicated data stores for your databases, maybe most likely for the TempDB and the transaction log. We also recommend that you consult your vendors because I've been mentioning 32 and 64 and 254 queue depth. It is not going to be beneficial for you to make changes on those on the vSCSI, for example, without a corresponding adjustment at the HBA and at the other array components. So we always recommend that you please consult your storage vendors, and they have the best guidance on what size of queue you should configure in your environment for a specific workload. There is this question of whether or not you should use VMFS or RDM for your storage, for your VMs. This question is very common, and it's been there forever. If you were to ask me this 4 years ago, I won't hesitate before telling you, yeah, use RDM. But we've closed the gap performance-wise between RDM and VMFS. So if the question comes up, I have to ask you, are you asking that question from a performance perspective? And if your answer is yes, it doesn't really matter anymore. RDM or VMFS have the same performance metrics. There is no difference in them. There are two corner cases where you may want to use RDM, especially for SQL workloads. The number one is if you were doing things like MSCS, or you're doing a SQL always on FCI configuration where the nodes share the same disks. If you have two or more nodes sharing the same disk in a vSphere virtual environment, we recommend, or we require actually, that the disks presented to them for sharing have to be presented as RDM, and that's just because we want to be able to remove the need for us to intervene in the SCSI reservation comments being sent from the guest to the storage. So if you present the disk as RDM, you essentially bypass the ESX VM kernel, and the VMs will be able to arbitrate the SCSI comments on their own. That's the number one use case for RDM in the vSphere environment. The second case is if your backup vendor tells you that they require RDM. Some do. if they want to do things like VSS-based or hardware-based VSS snapshot, in that case, they would need direct access to the disk. In that case, you would need to use RDM. Other than that, please, there is no technical reason from a performance perspective to do anything other than VMFS. I've tried to provide a representation of what we recommend for how you should break out your volumes and how you should map them to the storage presentation from within vSphere. I would like to caution that this is not an imposition. We are not saying this is the only way you have to do it. There are advantages and there are disadvantages to doing it one way or the other. I have a second slide that shows you a different way of doing this. Generally, we recommend that you break out the workload based on the characteristics, like take the log files and put it on a different volume, or take the 10 dB, put them on different volumes. If that's your standard practice, we encourage you to continue to do that. If it's not, we are not going to force you to do anything else or whatever you do today. The objective is for you to map those disks onto multiple data stores and onto multiple SCSI controllers. As I mentioned previously, what we're trying to avoid is you saturating the queue depth of a data store or a SCSI controller, and we also want to make it easier for you to ensure that you have successful backups, and we also want to make sure that you reduce your single point of failure. That way, if you follow this guidance, you will ensure optimal performance for your SQL workloads from a storage perspective. Here is another representation of that. I will let you, since you're going to get these slides, I believe, after this call, I will let you dig more into this. This configuration, the objective here is for you to reduce the number of drives that you're attaching to VMs by consolidating multiple type of workloads onto larger VMDKs and then a larger data store. The recommendation to still spread them across multiple SCSI controllers still remain the same, even though you are mixing them all inside the guest OS. Okay. I don't suppose there's any question yet. If there is, Tom, please let me know. Otherwise, we move into the CPU and other.
We've got several questions. If you're ready for them, we'll just kind of get through the list here.
Okay, let's do quick. Okay. Let's touch on the quick.
Is there a list of best practices to do on SQL Server and VMware? And I think you guys do have something up on your internet. Maybe you have it a resource slide at the end.
Yes, at the end of this slide, I have a lot of references for more reading. But if you just Google SQL best practices site /VMware.com, the first 3 results should include the last 2 reps of our best practices for virtualizing SQL Server on vSphere.
Okay.
I have the references included in the slides.
All right. And then someone asked, do you want to match VMware settings for NUMA exactly what the hardware has?
Yeah, I will go through that in this next couple of slides. Good question.
All right. How store port querying in Windows Server impacts storage performance? Are you going to cover that?
No, I'm not going to cover that because, well, if your OS is up to date, you probably have the most recent store port drivers, and the consideration doesn't change because you're virtualizing it. There's been some virtualization related issues with store port in the past. We're not there anymore now.
Okay. If a server uses a SAN and connects via fiber channel, should we do the same? Have more fiber channels?
Yes, the more you have, of course, the better. but it will depend on the hardware. What will be the maximum supported configuration for the hardware? Yes, the more lanes you have, the more paths you have for your IOs to get distributed through, the better the performance. The standard recommendation from our perspective is at least make sure you have 2 of each. 4 is will be optimal. But again, please speak with your storage vendor on what the support is and what will be the impact of having more and not less.
Okay. Can you please clarify increasing queue depth to a high number topic? Does this for which device? Do you recommend increasing queue depth to the highest number on all components in the I/O path?
That would be a yes question, but let me clarify. There are some parts where you can't touch the queue depth. For example, let's say you're using the LSI Logic SAS, 32 is 32. If you were doing vSCSI, you could go all the way up to 254. I think I have another session where I talked about what to do inside the guest OS to be able to get vSCSI to perform well. So I will skip that for now. But yes, you will ideally increase the queue depth along the path that the I/O has to traverse and make sure that they are in sync, they are aligned, because it doesn't benefit you to increase the queue depth at, let's say, the vSCSI, the SCSI controller, and then have the I/O bottlenecked at the HBA without, if you don't increase the queue depth at the HBA or the LAN. So this is why you will need to work with your storage vendors. They have the best guidance. You tell them you're running SQL Server on vSphere version XYZ, they will be able to tell you the best queue depth, even not just queue depth, the DSN arrow that I mentioned. I don't want to mention any vendor without mentioning everybody else, so I will refrain from doing that, but I know that there are guidance from the vendors on what the appropriate and the applicable queue depth should be across the storage stack.
All right, and then the last one we have, what's the best practice of size of disk cluster or block size, 4 KB, 8 KB, 64 KB on VM for Windows 2012?
This is why I mentioned at the beginning that the fact that you're virtualizing shouldn't change your consideration, at least not from the SQL perspective. 64 KB is okay if that's what you standardize on. It doesn't change. The consideration doesn't change on the vSphere environment. We don't do 4K right now, but if you were talking about SQL and you asking me about 8K or 64K, my answer to you is whatever you do today, the best practices recommendation from Microsoft, we incorporate that into our best practices, and we just base it off of whatever Microsoft is recommending specifically for SQL Server.
Okay, and that's all the questions.
Good. So let's talk about CPU. I don't know if you saw the first part of my slide, CPU 0 going really crazy and doing most of the work or most of the dancing and then crashing in the process. My objective is to help you avoid that situation. Let me quickly explain how we view NUMA and how we use NUMA in the vSphere environment for SQL Server. The ESS scaler is responsible for scaling requests for CPU cycles as they come from the application inside the guest through the OS and then to the VM kernel. We look at a physical hardware, modern hardware that you have today. We look at the partitioning. I don't suppose I need to describe what NUMA is. If I do, just let's say in modern hardware you have a block of CPUs and a block of memory that are local adjacent to them for optimal addressing. And on a motherboard, you have sockets and boundaries of that type of configuration where the CPU is divided into almost equal regions, and each of them has a bank of memory that are adjacent and local to them. Our objective is when you virtualize your VM and you allocate CPU and memory to those VMs, we want you to keep the memory and the CPU in a local NUMA or a NUMA boundary as much as possible, so that all the processes, threads, and requests for resources coming from the VM do not have to traverse and get serviced by memory from a remote region. Memory servicing from remote region is very expensive. It introduces latencies to your application. So in this example here, what we're trying to represent is a hardware with two banks or two sockets of our CPUs, each one with 8 cores, and you have the memory partitioned, and we have, in this case, we have a 96 gig of RAM. Let's take 2 of them, or 4 or 6 gig for, let's say, the ESX resources. And we're going to partition this into 2 equal regions, because we have 2 sockets here, and we're going to assume that each of these sockets has 45 gig of RAM to use. So if you create a VM with 8 CPUs on this hardware, and you give that VM 45 gig of RAM, the ESX scheduler is going to ensure that that VM is occupied or serviced within one of the NUMA boundaries. We'll keep everything local. So all your memory addressing from all the CPUs will be local and very fast. If you were to go beyond that, if you sized the VM with more than 8 CPUs or with more than 45 gig of RAM, what is going to happen is, in this configuration, we would need to service that VM request with a remote memory, and we may have to occasionally migrate the NUMA home for that VM, because we will see that there is an imbalance. If you have that VM here and we are addressing memory up here, we will see that there is not much activity going on here, and we may move the VM over to this region just to compensate for the imbalance. And then after a while, we will discover that this one we evacuated from is not being completely utilized, and we may have to bounce back, move the VM home NUMA to this boundary again. We may be ping-ponging that VM in that condition, and that activity will introduce latency and performance degradation to that VM. Again, the objective is, know your physical hardware, know the NUMA boundary, and try to size your VM to fit within a NUMA boundary. That is a generic recommendation. Now, we do know that you may have a hardware that cannot service a VM requirement in one NUMA boundary. In that case, it is okay to straddle NUMA boundaries evenly. So there are advanced configuration options that I've documented in this slide, where you can evenly distribute or partition that VM, intentionally partition that VM onto multiple NUMA boundaries. So the basic is keep it within one NUMA boundary. If you cannot, keep it within a multiple of NUMA boundaries, an even multiple of NUMA boundaries, or a divisor of NUMA boundaries. As long as everything is even, we will optimize performance for that VM. What do I mean by that? Let's say you have, in this configuration here, we have a 2x8 configuration. It will be better for you to have a VM that has only 8 CPUs and maybe less than 45 gig of RAM than for you to have a VM with 9 CPUs and maybe 50 gig of RAM or 52 or whatever. That extra CPU that you've allocated to that VM will most likely be addressing remote memory, and some of the other 8 will most likely be addressing remote memory. The expense of that remote memory addressing is not sufficient to justify that extra CPU. So it is not uncommon to see a VM with more CPU underperform a VM with fewer CPU. And this is why we say more is not necessarily better, which is why we always recommend that for your sizing effort, the basic thing for you to know is your physical NUMA topology, and then use something like DMV, Dynamic Management View, to actually trend your SQL utilization over a period of time and be able to determine the actual utilization and the actual resource requirement. Because as you know, as DBAs and as SQL architects, we know how SQL hogs resources even when it's not actively using it. Looking at Performance Monitor or Task Manager is not sufficient for you to say, this is how much my SQL Server is using. We ask you, we encourage you to use DMV counters, processor, memory to trend that utilization and use the real number to size the VM. Don't give the VM resources just because that's how the SQL was in the physical state. There is penalty to be paid in the virtual environment for over allocating resources to a VM. We will get into that shortly. The objective here is keep your VM size to either one single NUMA boundary, a multiple of NUMA boundaries, or an even divisor of NUMA boundaries to avoid the remote memory access penalty. This here is a representation of how you can calculate memory sizing and partitioning. I will just skip through this now in the interest of time. All right, so SQL has knowledge of NUMA. There is actually soft NUMA within SQL. Within our vSphere, we have a practice, a behavior, a standard behavior of exposing the underlying NUMA architecture to a VM as soon as you give that VM more than 8 CPUs. If your SQL Server has 9 or more CPUs, the OS will be able to see the underlying NUMA architecture, which would then be exposed to SQL, and SQL, being NUMA aware, can then optimally schedule threads and processes onto those the cores based on the NUMA architecture. We call that virtual NUMA. Now, virtual NUMA is enabled by default for a VM with more than 8 CPUs. However, there's also another feature in vSphere called CPU auth-add. CPU auth-add is what enables you to be able to add CPUs to a VM on demand. If you do that, if you enable that for a VM, we would not be able to expose virtual NUMA to that VM. It disables virtual NUMA. Simple. Now, you may be asking yourself, okay, which option should I choose? Because SQL benefits greatly from being able to see NUMA, we encourage you to not enable CPU auth-add for a SQL VM. We encourage you to do your homework, do the sizing correctly, and not expect to be adding CPUs on demand, to a SQL VM. All right. I said after 8 CPUs, if you have SQL servers that are going to have 8 CPUs or less, you can still expose virtual NUMA to them, but you have to do that intentionally. There is an advanced configuration option that I'm showing here, NUMA.vcpu.min, that you can use to control when you want to expose virtual NUMA to your VM. If you desire to expose virtual NUMA for a 2 CPU VM, you just put this advanced configuration option on that VM and it will be able to see virtual NUMA. I already mentioned the CPU output. NUMA best practices, I mentioned most of this already. Now, I In order for us to be able to expose the true underlying NUMA architecture to the VM, we require that when you allocate CPUs to your VM, there are two ways to do that. One by socket, the other one by cost per socket. We encourage you to always leave the cost per socket at 1. Don't change it to anything. If you leave it at, that way, then we will be able to mirror the underlying NUMA architecture to the VM. If you change it to anything, then that, whatever you've changed it to, is what we are going to expose to the OS and to SQL. Now, if you change it to something that doesn't really reflect what you have at the physical hardware, we are not going to question you. We're going to honor your design, we're going to honor your choices, and we're going to say, well, you know best. We say allocate CPUs by socket. If you want to give a VM 32 CPUs, give it 32 sockets. If you want to give it 64, give it 64 sockets, and just leave the cost per socket at 1, with only 2 exceptions. Depending on the OS version and the SQL version that you're running, that OS may not be able to see more than 4 or more than 8 sockets. In that case, you will have to allocate by a combination of socket and cost per socket. If you're not in that situation, if you have an OS that can see 64 or more, please size only by socket. The other exception is licensing. To keep your licensing costs down, you may want to reduce socket sizes and just use cost per socket. Those are the only 2 options, 2 exceptions. The other reason we recommend leaving the cost per socket at 1 is so that also when you vMotion the VM, you do not have to think again about what is the NUMA topology of the target hardware or the target host that I'm migrating to. If you leave it at 1, we will dynamically adjust for you if the NUMA topology is different between the original host and the target host. What will happen is if you have made a conscious decision to change the topology yourself, and then you migrate to a host that doesn't have the same topology, that VM will gradually start to lose performance, and you may have to reboot the VM in order to be able to get a optimal performance back again. All right, this is a representation of how you would do a CPU allocation. Again, in the interest of time, I'm going to skip it and make it an academic exercise for you to revisit after this call, after this session. The CPU, the VM itself really matters, what you do with the VM, especially on the Windows side. By default, the Windows power scheme defaults to balanced. Balanced CPU, balanced power scheme negatively impacts performance of SQL Server because Windows tends to put your CPU cores to sleep in that configuration. We recommend that you set your power scheme inside Windows to high performance, just like we recommend that you do at the physical host and inside the vSphere platform itself. Windows receive size scaling is another thing that introduces performance degradation to SQL Server, and I will quickly explain this. When you create a VM or when you have a SQL Server and it has multiple CPUs, let's say it has 4, 8, 16, whatever CPUs, without RSS, all the network packets and IOs from that VM will most likely be serviced by one CPU, which was what I was showing you in the animation. That CPU will be doing all the servicing of your network packets, and it will be saturated, it will be too busy, while the other CPUs are not doing anything if you don't have RSS enabled. And then what will happen is that CPU being busy, you will start dropping packets. those packets you're dropping, we will not be able to see it on the vSphere side because those packets are not making it out of the Windows OS. It becomes really difficult for you to troubleshoot. So we recommend that you always double check your RSS, make sure they are enabled. There are two places for you to enable RSS. I included that information in this slide. One are the Windows kernel, NetSH, int TCP show global, and the other one is at the NIC. You just right click on the network card inside Windows and look at properties and go to the configuration, and you will see receive size scaling. Make sure it's enabled in both places. All right. Let me quickly touch on memory, and then I'll take questions if there are any. Memory optimization. We don't change anything in this configuration. We recommend that you use large pages. It's the same thing you would do for SQL in a physical environment. There's no other special considerations. We're just calling out here some of the drawbacks of using a large lock page in memory, but this is not a virtualization phenomenon, so I would leave that unaddressed for now, but just be aware that if you're doing lock pages in memory, these are some of the challenges you may run into. Okay. If on your vSphere, in your vSphere environment, in your ESX cluster, if you're mixing workloads, if you're mixing your SQL Server, important SQL servers with other servers or VMs that you don't deem really important, and if you think that you are going to over-allocate resources within that ESX cluster, which means that down the road you may have resource contention, we recommend that in order for you to guarantee resources to the important SQL VMs, things like memory, when you allocate memory to the SQL VM, please reserve all the allocated memory. What that does for you is that when you get into a contention state, the VM that you've reserved memory for will not be impacted by the contention. That VM will always be guaranteed access to that much memory, whatever you've reserved. It also keeps your swapping. You won't see much swapping if you allocate equal amount of memory that you've reserved. All right. SQL supports memory add. Memory add is beautiful. We recommend that if you're going to do it, please do it only on vSphere 6.0 because we didn't get it right in prior version. Okay. I mentioned over allocation of resources. For SQL servers, for ESX cluster that will be running SQL Server, we do not recommend over allocation of more than 2-to-1 virtual to physical resources. As you know, virtualization does not manufacture resources. If the resource is not there, we will not be able to service the request. Microsoft supports up to 2-to-1, and we just mirrored Microsoft's recommendation. Do not, please do not look at virtualization as a consolidation opportunity for important SQL servers. If you were talking about other type of workloads like your web server or VDI or anything, then you will be looking at real high consolidation ratio. For important servers like your production SQL server, please do not exceed 2-to-1 consolidation ratio. All right, this is a representation of what happens when you have reservation and allocation equal to each other. We will create negligible or non-existent swap files. We don't swap at all. Network optimization, I mentioned the RSS issue, and I also mentioned earlier on that VMXNet3 is what we always recommend. Please, if you have any question on that, let me know. Jumbo frame is always very good. If you get your RSS right, you should not have any issue with VMXNet3. There are some known issues. Let me quickly, over here, if you're templating your guest and you have VMXNet3 included in that template, there may be some issues with depending on the OS version you're running. So I'm going to refer you to these KBs, both from Microsoft and from VMware. If you've done everything at the NIC level, you've increased, you've done, you're using VMX 3, you have Jumbo frames, and you've tuned your RSS, and you still have network packet issues or network throughput issues, there's an option for you to disable interrupt coalescing. We don't recommend that you do that lightly. Because it impacts performance from the CPU perspective. But if you suspect that you are not having good enough network throughput, disabling interrupt coalescing at the VNIC level is an option to improve performance for your network I/O. And I'm going to leave this here while I take Tom, let's take some questions, if there are any.
Yep, there are a few questions, so I'll give them to you here. If a VM fits within one NUMA boundary, will it not be moved if other VMs put extra pressure?
If other VMs put pressure, we will most likely migrate the most reasonable candidate. So getting fit within, getting into one NUMA boundary doesn't preclude us from using DRS as it's designed. When I said migrate in the previous slide, we are not actually moving the VM from host to host. We are actually moving the VM's NUMA home. That's a different a different construct from actually migrating a VM. The VM's home node, NUMA home node, is different from the VM itself. So what happens in the scenario I described earlier is a logical movement of where the VM is being serviced rather than a physical representation of where the VM is located. So yes, just feeding a VM within the NUMA boundary does not mean that we would not evacuate that VM if a DRS determines that it can perform better on another host. I hope that answers the question.
Okay. Do you recommend to set the NUMA.auto size to true for SQL VMs?
NUMA what?
Auto size?
You don't necessarily have to do that. You do that only when you suspect that you have an imbalance or you are not actually mirroring your NUMA topology. You do not need to do that. That's a behavior that we optimize for you, especially if you leave that cost per socket configuration at 1.
Okay. For SQL Server DBAs, what VM performance counters do you recommend tracking to make sure VMware is running perfectly?
Okay, so we ingest some counters into Windows through the VMware tools. We have no SQL specific counters in those metrics that we inject into performance counter. What you use today, when you go into perfmon, the same counters that you measure today on your physical environment are the same one that you are going to measure. If you have a SQL aware monitoring tool, I don't promote products, but since this question came up, let me mention we have something like vRealize Operations Manager from VMware, or any SQL monitoring tool that has SQL plugin. We recommend that you use that for your monitoring, because if it says that it's SQL aware, then it's most likely looking at DMV, and DMV is the authoritative source of whatever is happening at the SQL level. We recommend that you use those options for your monitoring exercise. At the vSphere layer, you will most likely be looking at things like latency, and you will be looking at cold stop, you'll be looking at ready. Briefly explain, percentage ready counter in vSphere is what tells you how long the VM has been ready to run a process, but it's not able to get CPU cycle or resource cycle. That usually tells you that either you've not given the VM enough resources, or the ESX host don't have enough resources to service that request. If you see your ready going up for a VM, look at the host that the VM is located on. If ready percentage ready is also going up, it means that that host doesn't have enough resources. But if it's going up on the VM and not going up on the host, that just means you've not given the VM enough resources. Wait time is when the VM is just waiting. And we want to reduce that as much as possible. And there may be a lot of things responsible for wait time. We don't have the time for me to delve into all those metrics, but use your SQL aware monitoring tool to monitor the SQL specific counters for performance trending.
All right. Well, I appreciate everybody's time today. Dexter Jones, you are the $100 gift card winner today. I will be sending you an email to follow up on it. This has been recorded, and we want to thank our sponsors today for actually doing it. Cisco is providing the $100 gift card to Dexter Jones. I will be sending out an email shortly, a little bit later, on the recording, so you can go back and listen to this and catch some of the slides that he actually went through a little quickly due to timing. Again, Deja, thank you for a great presentation. We appreciate it, and we look forward to having you back here with us in the future. Have a great day, folks. Thank you. Bye.